Okay, putting factoring to use. There's many ways we use factoring in college algebra and in algebra moving forward in this semester and in college algebra and beyond. Factoring is a very important basic skill, okay? But just learning how to factor expressions is like, what will I ever need this for? Okay? Well, because that allows you to solve equations, among other things. It allows you to solve equations, and those equations are related to functions that we can graph, and functions model real-world situations. Okay? So it all leads up to something. Factoring those is just the foundational skill. We're going to be solving polynomial equations. Okay. So solving polynomial equations. So we've got an equal sign now. Now your basic polynomial equations are linear. You already know how to solve those. That was from Chapter 2, specifically 2.4. Okay. So that was on the first unit. That was from 308. Solving linear equations. So linears are polynomial equations. They are degree 1 equations. Remember, the highest exponent tells you the degree. Linear equations, remember, we weren't working with exponents. Okay. Just like 3x plus 5 equals 7. Solve for x. Use your general strategy, kill fractions and decimals, get rid of parentheses, use your addition and multiplication properties to get x alone on one side and a number on the other. Boom, you got your solution. Okay? So the linear degree 1. Now this uses, we already know that's from Chapter 2.4, and this we use our general strategy. I refer to that as the general strategy when that little orange or green card that I gave you, basically we worked through in that review at the very beginning. That's just that list of things you do. First to clean it up fractions, decimals, and parentheses. What am I doing? Strategy. Yeah. Okay. And then using your addition and multiplication properties. Okay. So what we're doing now is and these are polynomial equations. Linear equations are polynomial. Okay. Polynomials are just terms that have all positive exponents. Okay? So an exponent of 1, you've got linear equations that have an x in it. That's x to the 1. Okay? So that's a polynomial. Even though it doesn't have another exponent you're seeing, you could write in the 1. Okay? So here, though, we're solving higher degree polynomial equations. Higher degree ones, you actually see the exponents, 2s and 3s and higher. Okay? So you've got quadratic, which is degree 2, okay? And cubics, which are degree 3. So your highest exponent in quadratic is a square, and your highest exponent in a cubic is a 3, a cube. And there are multiple methods for solving this. Today we are using factoring. Now, you can only solve polynomial equations with factoring if your polynomial expressions in the equation are factorable. Not every polynomial is factorable. If it's not factorable, you have to use a different method. Okay? So there are a couple other different methods. We're going to learn those towards the end of the semester. But right now, you can assume that any polynomial equation I give you is factorable. Okay? So at the end, I'll be giving you a mix. You can factor some, and you have to use other methods for others. But right now, assume it's factorable. You'll be able to take it all the way down to its linear factors and solve it. You won't have any exponents left when you're done.
That'll be on the test?
Yeah, solving these equations is on the test, yeah.
Okay, so you won't mix it this time, right?
Well, I'm not going to mix up with things we haven't learned. But the problems will be mixed in, as in the factoring methods. You use different factoring methods. I'm not going to put those, these are just binomials, these are just perfect squares. That'll be the factoring methods will be mixed up. But every equation I give you to solve will be quadratic or cubic, not higher degree. You do that in college algebra. Okay? And all of them will be factorable. You will use this method for them. We'll add other methods later. Okay? So this is all from Chapter 9, 9.4 specifically. Okay. Now, the quadratic, the general algebraic sort of definition form of a quadratic is ax squared plus bx plus c equal to 0. Now, it might not look that clean and pretty when you get it, but that's its basic algebraic elements. Okay? It's got a quadratic term, If it didn't have a quadratic term, it wouldn't be quadratic. Okay? If a were equal to 0, or if this was that means you wouldn't have a quadratic term, then you don't have a quadratic polynomial. You'd have a linear. See how it's only linear now if I get rid of the quadratic? Okay? So in order for it to be quadratic, it has to have a squared term. But it doesn't have to have a linear term. You could have a trinomial with quadratic, linear, and constant, or you could have a quadratic which is quadratic and constant, or you could have a quadratic which is quadratic and linear. Okay? As long as it has the quadratic, it's a quadratic, but it might be a trinomial or a binomial. It might even just be a monomial. That's still solvable. Okay? And it's quadratic. Cubic, its basic algebraic form would be ax cubed plus bx squared plus cx plus d. In this case, d is our constant, equal to 0. But the only thing that is required to make it a cubic is that it has a cubic term. It may not have all these other things. It may have all of them, or some of them, or none of them. As long as it has a cubic term, it's a cubic polynomial equation. Now, look how these are defined as being equal to 0. Look how all the terms are on the left, and it's equal to 0. That's very important. That's what's called standard form. Now, you might not be given an equation that is this pretty, but you've got to make it look this pretty before you can solve it. Okay? So, here are the steps, the rules. I'm going to go through the steps, and we'll put these steps in some examples. All right. So, 1, steps for solving these. 1. And I'm putting these steps in this order for a reason. Okay? So make this list. Later you want to go home and rewrite it with colors on an index card or whatever, study. This list I'm about to give you is important. Okay? The first thing you're going to do, give it a polynomial equation. Now when I say polynomial, I'm assuming a higher degree. You've already been solving polynomial linear equations. Okay? That uses your general strategy. If you've got a higher degree polynomial equation, your first step is actually the same as the first step for linear equations, which is clear any fractions or decimals. I'm just going to write fractions because I'm not giving you any decimal ones. Okay, but it's the same idea. If you did have decimals, you'd clear them first. Clear fractions, and also first fractions, and then clear any parentheses. Okay. If it's not already equal to 0 and you have parentheses, you have to get rid of them. Now, if you have some parentheses on the left, but it's already equal to 0, then you're okay. We'll see why that's true in just a second. Okay? But clear any and you clear fractions just like you do with linears, multiplying every term, whether it's a fraction or not, every term by the LCD over 1. Okay? Flatten it out. And I know we still had a lot of struggling with that on that first test. I haven't had anyone come to me and want to talk about any of those problems. I hope you are reviewing your tests, see what you got wrong, and if you don't understand why, come talk to me. Okay? Those skills are very important. That's not going away. You need to review and reflect on what you did before to see where your weak areas are. You need to keep practicing. This understanding of how to clear fractions, that doesn't go away. Okay? So if you weren't comfortable doing that with linears, it's still here. Make sure you get comfortable with it and reach out for help if you need it. So fractions and parentheses. 2, the second thing you do is put the equation in standard form. Okay. And these right here, that's what standard form is. Standard form. Standard form means all of your terms on the left and 0 on the right. Okay? So basically what you're doing here is you are setting it equal to 0. Okay? So anything that's on the right-hand side that's not, so if it's not 0 on the right, if it's equal to 0 already when you're given it, sometimes it is, you're good to go. But if it's not, anything that's on the right, you need to use your addition property, just like linear equations that use addition property to solve linear equations. The addition property works for any equation, as far as like moving things around. Okay? If you have something on one side and you need it on the other, just add the opposite. Okay? If it's positive over here, subtract it, but also subtract it from the other side. Keep the scale balanced. Okay? So once it's in standard form, it's equal to 0. Then pause a second, because this is one of those things you want to, what are my expectations? Okay? Once it's in this nice standard form, you need to ask yourself, what is its degree? instances, you'll see on like, I think, one on this activity, I think, and one on the homework at least, and possibly might show up on the exam. There's a case where once you clean it up and put it in standard form, it's no longer quadratic or cubic. It may end up being a linear if your other exponents cancel out. Right? That happens sometimes. So your degree might be linear, and you just go ahead and solve for x. Okay? Most of them are still going to be quadratic or cubic, but ask yourself that. Because what degree it is tells you two things. It tells you the number of variable factors. And by variable factors, I mean that they include an x. Okay? Remember, you can have other factors. You can have numerical factors. Like if you divide a 2 out of everything, okay, then that's a numerical factor, but it doesn't have an x in it, and it's not going to give you a solution. It is actually a factor if you're just factoring expressions like we've done so far. But for an equation, if you just factor out a number, yeah, that was a real factor, but it's not going to help. You can, at that point, you don't need it anymore, because if it doesn't have an x, it won't give you a solution. Okay? So when you pause here before you start because you're going to start factoring next, but you pause first and ask yourself the degree. Because whatever degree it is, if it's a quadratic with a second degree, then how many factors will that factor into?
Say it again.
If you have a degree 2, quadratic, once you've got a nice, pretty, and standard form, and you say, oh, that's quadratic, it's degree 2, how many factors will you have? 2. Yeah. If it's cubic, how many factors will you have? 3. You'll either end up with 2 linear factors or 3 linear factors. And when I say linear factors, that's another way of saying it's a variable factor. Linear means it has an x to the 1. It has an x in it. Okay? If you just have you pull out like a 2 or 3, you pull out a numerical factor, then that's not going to give you a solution. Okay? So that's the other thing it tells you. You're going to know, okay, I'm ready to start factoring. How many factors do I expect? I'm either going to expect 2 variable factors or 3 variable factors. Okay? And then that tells you, related to that, is how many solutions you're going to have. Because each linear factor is going to give you a solution. So how many solutions does that equation have? Bless you. How many, sliding back up here, how many solutions, when we solve linear equations, how many solutions do we have? 1. Right? X equals a number. Okay? So we had 1 solution. Now, how many solutions will we have in a quadratic? 2. And how many in a cubic?
3.
The degree tells you how many solutions you have, or how many possible solutions you have.
It could be more, though.
No, it could be less. It will never be more.
Okay.
This tells you the most possible solutions you can have. Now, that means the most possible real number solutions you have. You can also have imaginary solutions. That's coming later. You're going to have all real solutions here. So just like I said, everything's going to be factorable. So for now, since these are all going to be factorable, if it's degree 2, you will have 2 solutions. Okay? Actually, there's one exception to that. But it's not had to do with imaginary numbers. I'll show you an example of that. Okay? And you can expect 3 solutions for a cubic. Okay? So quadratic has 2 solutions, and a cubic has 3 solutions, and that's because of its degree. Okay? And and to be very precise, that's the most number of solutions you have. You may have less, but you'll never have more. Okay? Because each variable factor is linear. Okay? So I'm going to add that. It's number of linear. Because how do you know you're done? Everything's linear. Or if it's not linear, it's prime. You checked. Hey, that's not linear. Let me check. Oh, I can't go further. It's prime. In this case, everything will be able to. I'm going to give you everything I give you will be able to be factored down to linear variable factors. Okay. You won't have anything with exponents left that's prime. That involves imaginary solutions. We'll get to later. Okay. So the degree will tell you how many linear variable factors, and which tells you how many solutions. So having made note of that, that's your expectation. So that helps you also remember, when am I done? Okay. So step 3 then is to factor completely. Okay. And this means, just like we had the factoring overview last time, once everything is on the left-hand side, and it's equal to 0, you're in standard form, and you know how many factors to expect, you start factoring. Everything on the left, you start factoring. And this is where we get to 9.1 to 9.3. Where do I start? GCF. Still always the first question. None of this has changed. Okay. Now, if it's not in standard form, you can't start factoring. That's one reason we have to put it in standard form. Because they were like, you've got the party in the house over here on the left, you don't want to leave any of the guests standing on the lawn. Okay? Everybody has to be in the house before you can start making groups and having the party. Okay? So if it's not in standard form, you can't start factoring. Once everybody's on the left, then you start factoring. And that's when this comes in. First question is still always, do I have a GCF? If so, take it out. If it's just a numerical GCF, it's not going to give you, take it out. It's not going to give you a solution, but you take it out. Okay? And then ask yourself, do I have 4 terms? Okay, then group. Do I have 3 terms? Okay. Is it A equal 1, A not equal to 1? Is it a perfect square? I'm not going to give you quadratic and form. You can solve quadratic and form equations. You'll get that more in college algebra. I might include one as a bonus. Okay? But don't worry about that. You will have to do that for factoring, but not solve an equation with one. And, or is it 2 terms? Is it a binomial? If so, is it a difference of squares? Sum of squares would be prime. I'm not going to give you those right now because that would give you imaginary solutions. Okay? And I'm not going to give you sum or difference of cubes right now either. You do need to factor these things in the first half of the test. But for the equations, if you have a binomial, you're asking, is it a difference of squares? Okay? And if so, it factors into its conjugates. Okay? Make sense? Mm-hmm. Okay? So, that factor completely, this is all 9.1 to 9.3. Okay? And so you're going, but I'm not going to say, oh, this one's from 9.2 or this. No, once you see everything on the left, you got to go, how do I factor this? Okay? It's mixed practice. Okay? Do I have a GCF? Okay, what's left? What's my technique? How do I know I'm done? Okay. And then finally, once you factor into linear factors, factor completely, let me emphasize again, into linear factors. Okay. And you'll either have 2 or 3 linear factors. Okay. Unless it's, you might, like I said, sometimes the quadratic will cancel out and you'll end up with a linear, but that, it's kind of a weird special case, but you'll see it happen once or twice. Then you use, once it's factored completely, you use what's called the zero factor property. Okay. The zero factor property allows you to turn each linear factor into a solution. Each linear factor gives you a solution. Each linear factor gives you a little linear equation which you can solve, and that gives you your solution. Basically, you know how to solve a linear equation. Solving higher degree polynomials is all about breaking it down into linear equations, and then you solve the linear equations you already know how to solve. Factoring breaks it down. It gets rid of the exponents and turns it into linears, and you already know how to solve linears. Okay? Now, the zero factor property means this. Okay? If, let's say you have 2 factors, a times b, so a times b equals 0. Now, if you have 2 things that are multiplied, 2 factors, a times b, and the product, the answer is 0, what do you know about a or b?
They have to be 0.
Yeah, one of them has to be 0. Yeah, one or both. One in our case, just one we're working with. But one has to be 0. There's no way you can get 0 as an answer if one of your factors isn't 0. Okay, that's impossible. Any 2 non-zero factors will multiply to make something that's not 0. Okay. So, if a times b equals 0, then you know that either a is equal to 0 or b is equal to 0. One of those things has to be true in order for this to be true. So if this, then that. Now, that's true. It doesn't matter how many factors you have. You can also say, in the case of cubics, if a times b times c equals 0, then, same thing, either a equals 0, b equals 0, or c equals 0. So using the zero factor property means we set each linear factor equal to 0, and that gives us, so if one of our factors is x plus 3, we say x plus 3 equals 0. Solve for x. Each little linear factor becomes a little linear equation. Okay. So far, so good? All right. Okay. Oh, do remember, I don't know, I just total non sequitur here. But if you haven't gotten your test back, please remind me at the end of class, because I give them out the first day I have them ready to give out. But after that, I just carry them around. You've got to make sure and ask me if you have missed a class that you asked me the next class to give that back to you, because I'll just forget. All the grades are loaded, though. You can see that updated in my math lab. But to get your physical test back and be able to review it. All right. Okay. So, with that list in mind, keep that by you, because like I said, this order matters. This list matters. Let's put that to work in some equations. All right, so given a polynomial equation, x squared plus 4x minus 12 equals 0. Any fractions or parentheses? No. Is it already in standard form? Good. So if it's in standard form, you're ready to go. Everybody's in the house at the party, so we're ready to make groups, factor. If anybody's out here on the lawn, we'd have to move them over first. But sometimes you're already equal to 0, so you're good to go. So before you start factoring, though, make a note. What degree is this? So you're expecting how many factors when you start factoring? 2. 2 linear factors. Okay? And we know that, so now you start factoring. Is there a GCF? No. No GCF. Now, as I factor these, I'm going to be moving a little faster on the factoring. If you find yourself fiercely writing on, like, wait, I can get, that means, you need to practice that factoring technique. Okay? I'm focusing on solving the equations, so I may go a little fast on the factoring. I will scan in and upload these notes. Okay? But make a note to yourself, I'm not sure what she's doing there with the factoring. I need to practice that. Okay? Then look at the notes, try it again yourself and look at the notes after class and know I need to focus on that one. So I identify no GCF. Okay, next step, what do I have? I have a trinomial, quadratic trinomial, a equals 1. So all I need to do is my ACB and I'm done. It's going to make 2 binomials. Now you're not just doing an expression, now you're doing an equation, so keep bringing along that equal to 0. Okay, so a equal 1, so I know that I just need my sign pattern and I'll be done. My ACB will give me my 2 magic numbers. I need something that multiplies to make negative 12 and adds to make positive 4. I can do my little x over here. I'm not saying don't do that, but the more you can sort of get these a equal 1s mentally, all the better. Okay? Keep doing the strategies, whatever you need, as long as you need to. This is going to be a positive 2 or a 6, right? But it's also a 2. Yeah. So it's 6 times 2, which is negative 12, but we need a positive 6, so it'll give me a positive 4. And of course, that ACBX will get you there as well, and you've got a calculator backup for the bigger numbers. Okay? All right, so now I've had it in standard form. I factored it completely. I got the 2 expected factors. Okay? Now, this is another reason why it must be equal to 0. If this, notice the 0 factor property only works because you know if a times b is equal to 0, then either a has to be 0 or b equals 0. But if this were not 0, if this were some other number like 5, then a and b could be anything. I mean, that doesn't tell us anything. That's not a property. Okay? The reason it's important to have it equal to 0 is because then we know something about our factors. So if you are careless and don't put it in standard form first, if this is equal to something else, you can't use the 0 factor property. If this isn't 0, you can't use the next property. If you can't use the next property, you can't solve the equation. Okay? The 0 factor property says in order for this to be true, equal to 0, then either our a factor is 0 or our b factor is 0. Okay? So either this factor is 0, so whatever x is, if it makes this factor 0, then it doesn't matter what this is, 0 times this will equal 0. If I choose an x that makes this factor equal 0, you see how 2 minus 2, so x equals 2 would make it 0, then this would be 0. It doesn't matter what this is because this times 0 would equal 0. Okay? So these are 2 different possible solutions. And so I have 2 linear factors, and each linear factor gives me a linear equation by the 0 factor property. X plus 6 equals 0 is one of my solutions, or, because if that equals 0, the whole thing is, or if x minus 2 equals 0, then that'll make the whole thing 0, and that would be one of my solutions. Now, this is where a lot of times the brain freezes and go, what do I do now? You know how to solve little basic linears. Okay? But sometimes you put a basic skill in a new context. It's like, you know this, take a breath. You know how to solve for x. Okay? X equals 6. Okay? And x equals 2. Right. Okay. And those are your two solutions. Set notation. I can either use -6, and you go back and check. Now, just like checking linears, you can use your calculator. You make sure you plug things in parentheses. You can also use the store button and the test key. Okay, all the ways you checked your linear equations. If you need a refresher from that after class or via email, just let me know. But you can check it in the same way. You just have to check it twice. You check it with -6, and it will check. Good. And then you plug in 2. So you're not plugging in 2 and 6 at the same time. This is not an x and a y. Okay. Either 6 works, check, or then try 2 works, check. Okay.
So that'll be a final answer.
Yes.
To work it in that, you want us to work in those steps?
Mm-hmm.
Okay.
Yes. These steps are essential. Okay. You must clear fractions and parentheses first, and you must put it in standard form. Noting the degree, we'll know what to expect next. All your work, though, your biggest work, aside from just breathing, staying clear, this is the order I go in, your biggest amount of work is factoring. You've got to decide, what do I have and how do I factor it? Because it could be any of our techniques from 9-1 to 9-3.
So if it wasn't equal to 0, you would put the answer would be x plus 6 and x minus 2?
If it were not equal to 0 to begin with, then you could not factor it yet. You'd have to move anything that's over here over, and then you would start factoring. Everybody has to be at the party before you start breaking into groups. Okay? Now I'm going to show you an example like that in just a sec. If it's already equal to 0, you're ready to go. Everybody's at the party, you start factoring. Okay? First though, before I show you a couple more examples, I want to show you what this means, why you're doing it. Okay? This is transitioning then to working really heavily with functions in college algebra. Okay? So this is a single variable equation. It's a second degree, but it's still a single variable. We're just using x, not x and y. Okay? If you have a single variable equation, you can solve it for x. And because it was second degree, we had 2 solutions. X was 2 different things. Okay? Now, if you go ahead and write it like this for me. So let's say that y equals 0. Okay? Now, before you do anything, before you change anything, think about that. Think about the first unit. Think about working with functions in general and then specifically linear functions. If we had a linear equation, a linear function, and we plugged in y equals 0, what did it give us? Well, if it was only y, if the equation was y equals something, then that gives you a horizontal line. But let's say you have a diagonal line with an x and a y, and you plug in y equals 0. And it's going to spit out an x, right? It's going to spit out one of the infinite points on the line. If y equals 0, then you get an x. And what's special about that point?
The x-intercept?
Yeah. Well, not the origin. It's going to be, unless it spits out x equals 0, then you know the line goes through the origin. But it's going to spit out some x. Let's say you plug in y equals 0 and it spits out a 3, x equals 3. Then you have the point 3, 0. Okay? How many points on a line? Infinite points. Out of all those infinite points, only 2 of those points have a 0 in them. The x-intercept and the y-intercept. When y equals 0, you have the x-intercept. Now, for our purposes now, y-intercept is important another way, but it's not important for this reason. All we care about is the x's, the x-intercept. How many times does a line cross the x-axis? Once. How many x-intercepts does it have then? 1. Okay? So when you solve a single variable linear equation, you get x equals how